Hi, so this lesson is on how to write equations of tangent lines. The assumption here is that we don't know the formulas for differentiation yet, and we're just still going to work with the definition of the derivative. So when you need to write an equation of a line, there are two things you're going to need. One of them is you need a point, and the other one's going to be you need the slope. So if we know a point and the slope of the line, you can write an equation of that line using that. So first of all, we have the function and the x value, so we can find the value of the function at that point, which is going to be 5. So we have a point 2,5, right? But how do you find the slope? So the slope is going to be, in this case, the value of the derivative at this point. And now we're going to set it up using limit definition. So x approaches 2 of f of x, which is x squared plus 1, minus f of 2, that's 5, divided by x minus 2. So this is our definition, which is going to be the limit as x approaches 2 of x squared minus 4 divided by x minus 2. So we can use dividing out here. So it's the limit as x approaches 2 of x minus 2 times x plus 2 all over x minus 2. X minus 2 is going to cancel. Right, and then you are going to have, you can substitute 2 and the slope is 4. So just a really quick reminder, point slope form of a line, for the form y minus y1 equals m times x minus x1. This is the one that's most commonly used, and then you substitute the values. So tangent line is going to be y minus y1, which is 5, equals the slope, which is 4, times x minus 2. Now if you need that to be rewritten in any other form, like maybe slope-intercept form, you can do it from here, but we're just talking about the general idea how to write this. There you go, you got the equation of the tangent line. Next problem. Our function g of x is x squared plus x plus 2, and we want to evaluate that at, we want to write the equation of the tangent line at x equals negative 2. So just like with the previous problem, let's find g of negative 2. This is going to be negative 2 squared minus 2 plus 2. So it's 4 minus 2 plus 2, which is 4. So our point is negative 2, 4. And now we need to find the slope, and the slope will be g prime of negative 2. So we're going to set it up, the limit, as x approaches negative 2 of g of x, which is going to be x squared plus x plus 2, minus g of negative 2, which is 4, over x plus 2. Correct? So we have the limit as x approaches negative 2 of x squared plus x minus 2 divided by x plus 2. So this is going to be 0 divided by 0. We're going to have to use dividing out. So this can be factored. It's going to be factored as x plus 2 times x minus 1 over x plus 2. And x plus 2 cancels. Right? Now we're going to have the limit as x approaches negative 2 of x minus 1. And our slope is going to be negative 2. I'm sorry, negative 3. Right? So we got the point, the slope, the equation for the tangent line, is going to be y minus 4 equals negative 3x plus 2. Next problem. F of x is 4 over x at x equals 1. So let's find the value first. So f of 1 is 4 over 1, which is 4. So our point is 1, 4. So the slope, that's f prime of 1. That's going to be the limit as x approaches 1 of f of x, which is 4 over x, minus f of 1, which is 4 over x minus 1. We do need to combine those two fractions in the numerator. This is the limit as x approaches 1 of 4 minus 4x over x divided by x minus 1. So we're going to drop x down. So it's the limit as x approaches 1 of 4 minus 4x over x times x minus 1. Some simple algebra here. The limit as x approaches 1, this is still 0 divided by 0, but I can factor out 4 in the numerator, which will leave me with 1 minus x divided by x times x minus 1. 1 minus x and x minus 1 are the opposites of each other, so you can cross them out with negative 1 here. That means we're going to be left with the limit as x approaches 1 of negative 4 over x, and you can substitute 1 in here now, and the answer is going to be negative 4. Correct? So the slope is negative 4, the point is 1, 4. Now our tangent line is going to be y minus 4 equals negative 4, which is the slope, times x minus 1. Let me just remind you that this here was the slope. Okay, moving on. Got a couple more examples. So write the equation of a tangent line to the graph of g of x, which is 2 square root of x at x equals 4. So let's find g of 4 first, which is going to be 2 times square root of 4, which is going to be 4. So our point is 4, 4. And now we need to find the slope, which is g prime of 4. So for that we're going to do the limit, same thing we did earlier. X approaches 4 of 2 square root of x minus 4 all over x minus 4. So we need to use dividing out, rationalizing here, because we got that square root involved. So multiply by the conjugate, 2 square root of x plus 4, 2 square root of x plus 4. A little bit of algebra here we need to work through. So this is going, actually let's still do it here. Limit as x approaches 4 of, this is difference of squares on top, so it's going to be 4x minus 16 divided by x minus 4 times 2 square root of x plus 4. So in the numerator I can factor out 4. The limit as x approaches 4. If I factor out 4, I'm going to be left with x minus 4 divided by x minus 4 times 2 square root of x plus 4. As you can probably see, x minus 4 can cross out. So it's going to leave us with the limit as x approaches 4 of 4 over 2 square root of x plus 4. There's no longer any issue with 0 over 0. If you substitute 4 here, it's going to be 4 over That's square root of 4, 2 times 2 is 4, 4 plus 4 is 8, or 1/2. This is our slope. And now the tangent line is going to be y minus 4 equals 1/2 times x minus 4. In this case, both x and y values are the same. Okay, this is that. And again, one more example to show you, which is actually going to be quite simple. So they are asking us to write an equation of the line tangent to h of x at 2, -3, and we know that h prime of 2 is -2. So this here is the slope, and this is here is a point, and you actually don't have to do much. You just have to write all that in the correct form. So our tangent line is going to be y plus 3, y minus -3 gives you y plus 3, equals the slope, which is -2, times x minus 2. But what this problem, why this problem is important is because even though it gives you all this information, you need to understand what all these things that are given to you represent. In particular, what that h prime of 2 in this case represents the slope of the tangent line at x equals 2, and the point that's given to us is where x value is 2. So we can actually use all this information to write the equation of the tangent line in this case. Okay, I hope this helps.